There you go. Okay, so let's work again with the file that we worked with in the previous class. Was that, what was the file name? Big class, right? Yeah, and what I did actually, I cleaned up this file and posted that online on Scholar. Okay, so go to Scholar, and there in the Scholar, I started the new folder, well actually in the previous class, jump files. So over there you will find, I didn't post that. All that fuss for nothing, huh? Okay, so let's go ahead and start jump. Let's use our good old friend, big class family file. Remember how to find all these files that are supplied with jump? You have to, probably you can find it here actually, right? In the list of files. Is it empty for you or is there something? There is something in there, right? So you can just double click and it will bring up the big class families, right? That's the file that I was planning to post. How is it different from what you see probably? You see a lot of green triangles over here, right?
Yeah.
Yeah. So that's the file that was worked with by Jump, so they have some stuff. I don't have anything right now, so you will see what happens as we go. So let's actually reproduce a couple of charts that we created in the previous class, but before we start, I want to kind of put these things into the organized way, okay, organized fashion. So we discussed that probably very popular charts, one of the most popular charts used in statistics and visualization world are univariate and bivariate charts. Univariate means what? You plot one variable at a time, right? So let's create an inventory of charts, right? That we're kind of learning. Univariate charts. Okay, what do we have? Well, in the univariate charts, they're all bar charts, essentially, right? Well, that's not true, actually. Okay, they're not necessarily all bar charts, but these are the most popular univariate charts. And, well, let's just call a spade, right? Bar chart, okay? Bar chart. Okay? And bar chart is used for categorical data. Okay? So if your data is nominal or ordinal, then you're using the bar chart. So categorical data. Okay? And then if we have a continuous data, numbers, we can also plot the bar chart, but it has the special name, right? How do we call bar chart for continuous data? Histogram, right? So histogram, if the data is continuous. Okay? So univariate is called univariate because it shows you one variable at a time, correct? All right. So very useful charts and very usable charts are bivariate charts. Bivariate. Bivariate means they show you two variables at a time, right? So one thing that we did in the previous class was what? We plotted a bunch of dots, right? From this file that we're looking at, big class families, right? We plotted what? Weight versus height, right? How did we call that type of plot that just shows you a bunch of points? Scatterplot, right? So scatterplot, and scatterplot plots continuous versus continuous, right? Continuous versus continuous variable. So both of your x and y are continuous variables. Weight is continuous and height is continuous, right? Okay, let's actually go ahead and now reproduce these two. So we're going to come back to this thing, right, and write more things, okay? So let's go back to our file, and let's reproduce again what we did before. So first thing I believe we did was distribution of gender, right? Single univariate distribution of variable sex, which is nominal variable, right? So therefore we're talking about bar chart, right? And it's really easy to create. So click on the button distribution, right? Then take the variable that you want to plot, put it in the Y area, and then you click OK, and there it is. So it's the distribution of variable sex, okay? Now, if I want to turn it around, I have to say stack from the rectangle menu, right? So here it is. It's a bar chart, right? Horizontally it says what are my categories, females versus males, and vertically it shows me counts, right? Now, here's what I can do, okay? And probably I will ask you to do that during the exams and quizzes. When you do the analysis, I want you to save this analysis into the file, and then save the file and email it to me. So how do you save your work? Here it is, okay? So if you go to the red triangle menu, right? Everything that you can do with anything in JMP hides in the red triangle menu for the most part. So red triangle menu, and at the bottom you see the option that says save script, right? If you choose to data table, okay, I'm going to call it distribution of sex. That's fine. Okay, distribution of variable sex. And then you click OK button, and look at that. I actually have, I had this area empty, right? A triangle showing up. Green triangle and the name what I just saved, right? So now, and you probably have it also, right? At the bottom, like at least still there, but you have one more, right? So what happens if I close it? I can go ahead and click the green button, and it will run this thing all over again, okay? So that's how you show me your work. When you do the problem on the quiz or on the exam, you just save script to the data table, and it becomes part of your file which you email to me. Michael?
Are we going to have, like, on the study guide, maybe like a reminder of like how to like do all the steps?
Yeah.
Like, what to collect and like how to save it?
Yeah. I'll put it on the, I mean, you can ask me if you forget, right? It's not something that, you know, I'm going to give you a D for, right? Oh, man, he doesn't know how to save things. No. I'll put instructions, but after you do it once, twice, you got it, all right? So, first thing. And also what I wanted to point out is something else. Let's create a distribution of one variable. So another one, histogram, okay? So this time around, I'm going to create a distribution of something numerical. It can be either height or weight. Let's do the height, okay? So again, go to the distribution and just drag the height into the Y area and click OK. And there it is. Here is the distribution of continuous variable, histogram of continuous variable height. Let's turn it around, stack. Now, you can see that JMP not only gives you a distribution itself, but it also gives you this weird looking thing on the top, right? You all took statistics, BUSN 31. Do you remember how this thing is called? Box and whiskers plot, right? So what does it tell you, box and whiskers plot? Let's kind of take a look. Well, first of all, box and whiskers is built around three things. The box, right, is built around three things. You can see there is vertical line number 1, there is a vertical line number 2, and there is a vertical line number 3. And then there is a box around them, right? What's line number 1? Lower quartile, exactly right. First quartile, or 25th percentile of the data, right? So it's basically the number that separates 25% of the data below from 75% of the data above. So second line is the second quartile, which is median, right? It separates 50% of the data below from 50 above, and that's 75th percentile or third quartile, okay? Then whiskers, they go to the right and to the left, and they can reach the maximum length that the whisker can be. Anybody remembers? How much is the maximum length of the whisker before we start, before we terminate it? It's the interquartile range, which is the width of the box multiplied by 1.5, okay? So, look at that. What we do is we continue the whisker on the right, and then once it reaches the last point, apparently, so whichever one comes first, you reach the point, and there is nothing else going on, so that's where you terminate it, or you reach the maximum length and you stop the whisker. And if there are any points left outside the whisker, what do we call them? Outliers, right? So on the right, there are no outliers, right? Which means that we reached the last point, which was close enough, and we stopped the whisker, right? There is nothing else beyond that. But on the left, what happened is we have the whisker, right? We stopped it because we reached 1.5 times the box width, interquartile range, and there are 2 points that are way out there, okay? These are outliers. So because this is distribution of height, these are 2 people who have unusually low height, right? And you can find them actually. Remember, I told you that there is an interaction going on between the data and the data table and the plots, right? So if I highlight these 2 points, it's very easy to do. I highlight these 2 points, and there they are, okay? So in my data file, that's Robert and Lily, okay? So question then becomes, what do we do with outliers? What would you do with outliers? Well, there are 2 things, right? We can either leave them in, or we can get rid of them, right? So what would be the reason for us to get rid of outliers?
Oh, like to get rid of them?
Yeah.
So it doesn't like skew your data?
Doesn't skew data, that's right. That could be the reason. But essentially, this is the legitimate data, right? It's not like we made a mistake, right? We recorded the honest measurement of the data. These 2 people just happen to be on the low side, right? So they're part of the population, right? There are people who are, short, right? They're not very tall people. Just like on the other extreme, there are tall people, right? That don't look like the rest of the population, but they're still part of the population. So generally speaking, probably we want to keep outliers in the data, okay? Unless, of course, we can find something that's wrong with these outliers. Like, for example, let's say if these 2 outliers were not, whatever they are, like 50, what was their height? 52 and 51. And that would be, inches probably, right? But let's say that these 2 outliers were 15 inches and 23. Do we want to keep them? No, right? Because it's just probably some error, right? People cannot be 15 inches tall, right? So apparently somebody who collected the data, they made a mistake or maybe mistyped something. It's called transposition error, right? Instead of 51, they typed 15. Happens, right? So if you can really identify that there was something wrong with this data, it was either not collected properly or not recorded properly, so there was an error. And yes, we probably want to exclude them from the data set. But if these are legitimate measurements, it is what it is. We're just going to have to keep it, okay? So I just wanted to point it out so that, we know the issue of outliers. So every time when you see the outlier, you have to decide for yourself what to do. All right, so I'm going to close this one, and let's recreate another plot that we did in the previous class that was Scatterplot, right? So for that, I have to go to Graph, Builder, under the Graph menu. And what did we plot? Weight versus height, or something like that? Yeah. So let's do the weight, drop it in the Y area, and let's get the height and drop it into the X area. And here is the smooth line, right? And remember, we discussed that on the top, I have different buttons, image buttons, right, that I can click. And basically, they're going to replace the type of chart that I see in front of me, right? So if I want straight line, there it is. If I want the correlation ellipse, that shows me correlation, how strong is the correlation between height and the weight, there it is. So if I want multiple things simultaneously, I'm going to select one of the views, for example, Scatterplot. Okay, there, Scatterplot in place. I don't want the correlation ellipse, so I'm going to unclick that. And after that, for example, if I want this line, zigzag line, right, then I can just go ahead and drop it on the top of my chart. This way it keeps whatever was in place before, right, and also plots something else, the line, okay? So we did that in the previous class, I believe, right? So I'm going to click the button Done, and I'm going to save this chart also into my file, just like I did before. You remember how to do it? Go to red menu, right, red triangle menu, save script, save to data file, and it says weight and mean weight versus height. Well, I'm probably going to rename it. It's really weight. Yeah, it is weight and mean weight because it has two things, right? Scatterplot means I'm plotting weight, and this zigzag line, I'm actually connecting the average weights, right? So, but let me just simplify it. I'm going to say weight versus height scatterplot. Scatterplot, oops, of weight versus height. Simple as that. And when I click OK, I have another record, in my list of things, list of analysis that I did, right? Okay, cool. Now let me go ahead and run both of them, because you have to have both things open for us to run the dashboard, right? Let me show you what dashboard looks like. And we did dashboard, so we're going to quickly recreate it again. Then I'm going to point out how you can share the dashboards, okay? Remember how we start the dashboard? What do we have to do? We go to the file, we go to the new, and pick File, New, Dashboard. Okay? And dashboard essentially is the place, it's a page, whatever you want to call it, space where we put multiple visualizations together. And these visualizations essentially represent different slices of data, right? Different views of the same data, right? Typically, we want visualizations and dashboards to be usable, right? They should tell whoever is looking at the dashboard essential features of your data, right? So I believe what we did is 2 by 1, right? Because I have 2 charts open. So here's my 2 by 1 dashboard, okay? And simple as that. I can click. This is the list of charts that I have open, right? I can click on one chart and just point where I want it to be placed, and it goes there. Or I can drag and drop, right? So this one goes in here. So this is my simple 2 by 1 dashboard, okay? So I took my chart 1, chart 2, placed them in 2 different halves of my dashboard, and there it is, okay? All right, so let's run the dashboard. And you can do a couple of things, right? So here is the button that says Run Script, or you can go to the red triangle. Everything in JMP is in the red triangle menu, right? And go to the red triangle and say Run Dashboard, same thing. All right, and that's what we did in the previous class, right? Now, what's cool about this dashboard is it keeps interactivity. So in other words, if I click on the female column right here on my bar chart, it highlights the points for me that are female observations, okay? If I click on the male, it highlights points that are on the male observations, okay? Now, what doesn't happen is it does not change. It may be that the line looks differently for males and females, height versus weight, right? But line doesn't change, okay? So how about this? I'm going to close that dashboard. Not save it, just close. And close this one also, the design, all right? Without saving it. And go ahead and reopen another dashboard. So go to the File, New Dashboard. And now what I want to do is I want to use this one, this design, that says Filter +1 Dashboard. So in other words, I have 2 charts. One of them serves as a filter for another, okay? So go ahead and click that one. And you can see the funnel, right, on one of them. So that's the filter part. That's what's cool about that. So I'm going to do the same thing. I'm going to use my bar chart right here as the filter, all right? And the other one as the +1. And let's see what happens. So I run the dashboard. And that's how the dashboard will look for the user, okay? And look what happens. If I click on the female, it filters out only females, right? So the points that are for male students, they're dropped out, okay? So it shows only female points, filters them out, okay? And the line that is fit into these points is dynamically updated, okay? So it's new set of points, it's a new line therefore, okay? And if I want just the males, you go ahead and click that. So it becomes dynamic and interactive, right? So you click one, you change something on one of the charts, the rest of the dashboard responds to that, okay? And that's actually a standard feature for pretty much any visualization package out there these days, okay? Now, JMP is fairly powerful this way, okay? So you can create dashboards, but it doesn't come close to the other program that we will look at next week. That is Tableau. Okay, Tableau is one of the most popular packages for the visualization. The downside is that the only thing that Tableau can do is visualization. Okay, so JMP can do a lot of other things: statistics, data mining, all these machine learning techniques that we will discuss during this semester. Tableau does just one thing and one thing only: visualization, but it does it really well. Okay, and there are other programs as well. I'll talk about that when we get to the visualization in Tableau. Now, how can I distribute this thing? You realize that the bottom line, why am I doing all this freaking analysis? What's the main big idea? Well, who is going to use this stuff? Well, that probably is not very useful, but let's say I created a dashboard that shows you sales, broken down by quarters or months and by regions and by product categories. So who will use that data?
Well, I work in retail, and I'm interested in getting into retail management. And, we have to look see what our sales plan is for each day.
Mm-hmm.
And we have to see what it was in conjunction with what we did the day before.
Yep.
So it's have all these parts. So probably just that. When it needs a good really detailed chart that you breakdown.
Yep. So this type of analysis is used for decision-making purposes, right? Are we doing better today or this quarter than the previous quarter? How does that compare to the previous year, right? Are we going up or are we going down? What are the costs doing, right? So managers or decision makers, broadly speaking, need to take a look at this stuff, right, and then make up their mind. If I'm a data analyst working for the company, I want to share that file, that analysis, with people, right, in the organization. So let's see how we can do that. Here is another cool feature. I don't know if it's cool or not, actually, but how do I save this, right? How do I share that? I mean, I can save the file and I can send it to my boss, and if he has JMP, he'll be able to open it and run the dashboard and see everything for himself. No question. But what would be nice is we don't have to buy a separate license for 50 people in an organization just to be able to open JMP file, right? Dashboards I should be able to share with anybody and as simply as possible, right? They don't need JMP to see the visuals, right? So here goes, right? There is a hidden menu that you don't know there until you point. So if you go on the top, and do you see that bar, kind of very thin bar up there? Yep. If you position your mouse over that, it kind of shows up, right? But this is where I can save my dashboard. So go ahead and click on the Save button. Kaboom. All right, and I'm going to just save it right here. Or you can put it on the desktop. That's probably easier, right, thing to do. We'll put it on the desktop, and let's see what are our options. Save as type. Let's take a look. What are the types available? I can save it as PNG file or JPEG file. What are PNG and JPEG? Anybody knows? Pictures, right? Static picture. So if I save it as PNG or JPEG, all I'm going to get is that picture that I have right now. Is it going to be interactive? You can click and see things change. No, it's just a picture, image, right? PDF, same thing really, right? I share the picture essentially, only it's in the PDF format. Okay, I can create a PowerPoint, and probably it's going to be not interactive as well. Quite honestly, I never tried that. So, interesting question to ponder. But here is the cool thing, okay? It can be interactive HTML. What's HTML? What's HTML?
Hypertext markup.
That's right. So, simply speaking, HTML is a web page, right? And that would be cool, right? If I can save the dashboard as HTML, and then send it as an attachment to my boss, when he clicks on that, how does that open? It opens in the browser, and everybody has the browser, right? So therefore, it would be great if I could save, let's try that, save it as HTML file, okay, and just give it any name. So right now it says dashboard HTML, that's good enough for me. So dashboard.html, and that's a web page. Yeah, so save it as an HTML file, and let's see if it actually works. So go ahead and click on the Save button. All right. So hopefully I have HTML file saved on my desktop. Let's see. Let's take a look. Here's my desktop, and where is my HTML dashboard? Can I find it? Yeah, dashboard.html. Cool. So now, if I go ahead and double click that, it opens up in my browser. Can you see that? It opens up in my browser, right? Now, here's what sucks, quite honestly, okay? And they promise that they will fix it maybe in a year or 2 years. it would be nice if the page preserved all of its functionality, right? Like I'm clicking on males and females, it filters out the point, it updates the charts, right? Well, unfortunately, not the case. So you can send a file, right? The HTML file, but if you start clicking around, you can see that it loses all of its interactivity, okay? Because it's not easy to create a web page that has all of these bells and whistles that are, built into the JMP. So right now it cannot be interactive if you save it and send it, to other people in the organization as HTML. But probably a year, couple of years down the road, it's going to be. You click it and it updates itself. It's just technically it's not easy to implement. All right. Any questions? Yes, sir.
Where would you go to save the dashboard?
Oh, to save the dashboard in the JMP? Okay, here. Where's my dashboard? Here's my dashboard, right? There is a hidden menu right there. If you're not pointing to that, it hides. So on the top, like if you point your mouse right there, like this thin strip, then there is a save button. Ellie?
If you save it as a interactive HTML, it works. Like you can click around.
Oh, really?
Yes.
Okay, let's try that. So HTML interactive, right? Not just simple HTML. Okay, HTML with data. Let's try that. And I'm going to replace that thing. Kaboom. And let's see. That's how it looks.
It like highlights the different points.
Yeah, but the line doesn't change, right? The line itself. It highlights points. If you switch between males and females, it highlights males and females, right? But it doesn't change the line itself, right? It does? Does it change? No, it doesn't change the line, right? Yeah. So it loses some of its interactivity, okay? So this technology is not quite there yet. But that problem is non-existent for Tableau, believe you me, okay? So when we're going to do Tableau next week, you will see just how awesome and powerful Tableau is, okay? So visualization is not a strong suit for this specific package. Henry?
I received a message that says JMP quit unexpectedly, and it just shut off.
Yeah, happens. Just restarted.
Okay. All right.
Yeah, so that happens. All right. Now, what else we're going to discuss today? Hold on. Let's take a look at a different problem. Okay, we have about 15 minutes left today. The bivariate plots, right? So far, we studied what's that? Categorical variable. Oh, sorry, continuous variable versus another continuous variable, scatterplot, right? I can actually create a more a different type of the bivariate plot. So, for example, let me go back to JMP. Even the same file, right? So I'm going to close all these things that I have opened. Let's go back to the file, actually. For example, let's say I want to take a look at distribution. How do males and females compare in terms of distribution of height, for example, okay? So horizontally, I'm going to have two categories, males and females. Vertically, I want to show somehow the distribution of heights for males and distribution of heights for females separately. So my X category, X-axis, will contain a nominal data, gender, males, females, and vertical axis will contain continuous data, height. Okay, can I do that? Well, let's try. Let's go to graph. Graph builder, same thing. Okay, so I'm going to take the variable sex and drop it into the X zone, and it shows me two bunches of points. Michael.
Does it matter what variable we put on which axis? Does that matter?
No, it's going to just flip it. And that's it, pretty much. So essentially, what you have to do is make sure that it's easy to interpret, right? That's it. So it's just a bunch of points, right? And the reason why they look like cloud is because I have jitter going on, right? Remember we discussed that in the previous class, jitter. If I unclick jitter, it will be just, oh God, that's a little extreme. Yeah, all right. Okay, so the reason is because I put males and females, but what exactly is that, right? What is it? Count? Is it like what is going on? Count, probably, right? All right, so, and I want to plot the height vertically. So go ahead and drop height in the vertical area, into the Y zone. And now it shows me a bunch of points that are different, right, from what it was before. And the reason, again, why they're so cloudy is because of jitter, right? If I turn off jitter, it's going to be just, here is a bunch of measurements for the males, and some of them may be duplicated, one on the top of another, right? So if points are in the same place, it looks like one point to you. So what jitter does is it introduces this spread effect a little bit. It doesn't show you really anything. Okay, so what can I do with these things? Well, typically, if I have this type of plot, it's a bivariate plot, nevertheless, right? It's variable x versus variable y, variable sex versus variable height. Okay. Well, what I can do is go ahead and click on the bar chart, and what it will show is the average, right? It's how the males and females compare on average. So, and if you position your mouse over one of the bars, it will tell you name, Alice, Amy, Barbie, so all the girls basically, right? And the mean is 60.9 inches for the girls. If I do the same thing for the males, then all the names, and the mean is 63.9. So what does that tell you? That males just a little bit higher, taller than females, right? That's it. Alternatively, what I can do is go ahead and click. Oh yeah, and if I want to have points at the same time, probably I don't, but yeah, if I go ahead and drop the points, we can just drag and drop the points on the top of my bar, right? Alternatively, I can go ahead and show the box plot. Remember we discussed box and whiskers plot today? So if you show the box plot and also the points right there, so it basically shows you the distribution of, like shape of the distribution, right? So this one says that as far as the height is concerned, there are 2 outliers among females. We knew that, right? We looked at that today, right? We knew that there are several outliers for the height. So between females, there are 2 outliers right there. And among males, there is 1 outlier, person Robert, which is 51 inch tall. Okay, so that's pretty much what we can do. This is another form of plotting by a bivariate plot, right? But unlike the scatterplot, which is continuous versus another continuous variable, this one is continuous versus categorical. It's either nominal or ordinal, right? So let's go back to our listing of things, right? So bivariate plot. So we can plot also continuous versus categorical, right? And can be also bar chart, right? Or we can have, like what we did was for each category, plot a box and whiskers, right? Or box and whiskers for each category, okay? Now, do you see where I'm going with this? It's continuous versus continuous. Continuous versus categorical. What's the next? In the class of bivariate analysis. 2 variables at a time. I have continuous versus continuous, continuous versus categorical, and the next one, natural extension, would be what? The last one.
Categorical versus categorical.
Versus categorical, right? So what can we do for categorical? Categorical versus categorical. Okay, what is it? Well, this is something that we're going to actually have two things about that, okay? There is a tabular summary which is called contingency table. You will see exactly what it is in just one sec. Contingency table. Contingency table. And also, what comes with contingency table is mosaic plot. Mosaic plot. Okay? All right, contingency table and mosaic plot. Well, let's take a look at that, okay? And for this, we're going to need a different example. So go ahead and close all of that. Close all. Whoops, apparently my jump also quit. Yeah, at least it looked like that. All right, well, no, we didn't. Jump is still here. So you're back to the main window, right? Go ahead and open help, tip of the day. No, not tip of the day, sorry. Sample data library. We don't want to look at tip of the day. Sample data library. That's where a lot of different files that are supplied with JMP are located, right? and go ahead and find the file that's called Titanic. You know what Titanic is, right? What is Titanic? Can you tell me? Where is Titanic? Yeah, Titanic, right there. Okay, so you found the file? Tell me what is Titanic? Yeah, really big ship that didn't even make one trip and sank halfway between England and the United States, right? Because it hit the iceberg. So you can see that this is the listing of all passengers from the Titanic. Okay, how many people altogether? 2,000, yeah, 2,200 people, right? Some of them are selected for some reason. I don't know why they come selected. Let's deselect them, right? You remember how to deselect? Click on in the top corner, it deselects everything. So this is a simplified version of this file. Actually, in the data library, in the sample data library, there's another file that has like names, ages, and all the other details. So right now, what we have is a simplified version of this file. Okay, so 2,200 passengers, and each passenger, there are how many variables are in this data set? 4 variables, right? One variable is survived. Yes, no. Yes means that this person survived the crash, right? No means that the person drowned, right? So yes or no. Okay, then there is same thing, sex, male, female, right? Then there is age. Now age is not very what's the word I'm looking for? Not very detailed, right? I believe this data set is actually split as far as the age goes into the 2 different things. It's either adult or a child. So how do you classify a person if he's adult or a child? You decide on the cutoff age, right? When people start being children and become adults. If I would ask you, what would you say? 18, cool. So therefore, everybody under 18 was treated as a child. If a person on the Titanic was 18 or older, they said, okay, that's an adult. Okay. Then class. Class means the Titanic was, I believe, subdivided into different classes, right? You've seen the movie? Anybody not seen the movie Titanic? This chick flick kind of sappy thing, right? Okay. I believe the data file, this data file contains 4 different categories. And all these variables, by the way, are categorical, agree? None of them are numerical, right? None of them are continuous. It's categories, right? And as far as the class goes, there were first class, second class, third class, and the crew. Okay? So, remember what we discussed just now, that I can have a 2-dimensional, not 2-dimensional, bivariate analysis for categorical variable versus another categorical variable, right? That's a good example to use, because we have a bunch of categorical variables. So how about that? I'm going to take a look at, does gender affect your survivability on Titanic? Okay? So here's what I'm going to do to create the mosaic plot and the contingency table. Okay? I go to this click button, fit y by x, or you can go through analysis, fit y by x, right? Same thing. Okay? And look at that. What's good about this is it shows you graphically. Here is a little kind of helping picture for you. Okay? It shows you what type of analysis are you going to get depending on what's your x and what's your y, what's your variable 1 and variable 2. So here I have categorical variable versus categorical variable, right? My x is categorical and my y is categorical. So therefore there is a contingency table, and it comes kind of package deal. It comes together with the mosaic plot. So let's do that. I'm going to put y survived, yes or no, and x is the sex, male, female. And when I click OK, there it is. Okay, so here is my contingency table, and it even says so, contingency table, right? And here is my mosaic plot. So let's take a look at what does it tell you. First of all, do you see that bar right there? And you can resize these things. That's what's cool about that. Okay, so the bar that's on the far right, it shows you in the overall sample, 2,200 observations, what was the breakdown between people who died and people who lived? Okay? Everybody, females, males, females, everybody. So, therefore, what do you see? Most people on Titanic died, right? Because survived equals no. In fact, if we point to this area, it says 67.7% of passengers drowned. okay? And only, 32.3% survived. Now, this one has actually a more detailed breakdown for you, okay? Well, first of all, let me point out this. Why do you think males is the wider part and females is the kind of more narrow part of this graph?
There were more males.
More males than females, exactly. So, therefore, horizontally, it shows you what was percentage, if everything is 100%, what was the breakdown between your different categories, okay? Now we have two categories, so it shows you that males represented a much bigger proportion of passengers of Titanic than females, right? And what can you tell me about survivability? Who was likely to survive, males or females? Females, right? Because if you look at males, right there it says that 78.8% of males died and only 21.2 survived. In the females, the survival rate was actually 73.2 and only 26.8 of them died. So this is a graphical representation. So this is mosaic plot, okay? All right, now what's the contingency table? This one. Contingency table essentially tells you, communicates to you the same exact information, only numerically, okay? So right there it says, for example, we have sex, male versus female, right? And you can see that each cell contains 4 numbers, right? 1, 2, 3, 4, 1, 2, 3, 4. So in the bulk of this analysis. This is the sort of a tooltip for you, okay? Help for you. How to interpret these numbers. First one is count. Another one is total percentage. So total means what? Out of everything, right? Out of this total number, 2,201 passengers, right? And then percentage in the column, what this number represents, and the percentage in the row, what this number represents. We have 2 minutes, right? Let's see if we can cram it. All right, so out of 2,200 passengers, females who did not survive, the count was 126, and females who survived, the count was 344, right? So these numbers, 126, 344, 1364, and 367, if we add them together, what are we going to get? 2201, right? Total, okay? So total percentage, that means that out of all passengers on Titanic, 2201, right? Females who survived represented what? Females who did not survive, right? 5.72%. 15.63% survived. For the males, it was 61.97 versus 16.67. If we add these percentages together, what are you going to get? 100, right? That's everything. Okay, so last 4 numbers, right? This one, it says column percentage, right? How are we doing on time? Are we? We're out? Okay, so to be continued, right? So on Monday, we're going to finish interpretation of the contingency table, and we're going to look at some other charts that are not univariate or bivariate, but something else, some more advanced charts, okay?